Hi, I'm Michael Herrsche from IBM Research Zurich, and I'm presenting you our work on soft masked diffusion language models. Masked diffusion models are a viable alternative to autoregressive models. Instead of generating an answer token by token, diffusion models generate the answer by iteratively refining a noisy answer. In masked diffusion models, the noise is represented by a dedicated state, called the mask or absorption state, shown here with white blocks. A denoising model, for example a transformer, then predicts the content for all masked states. However, just a fraction of the prediction is maintained, while the rest is remasked. This binary choice about maintaining or remasking a token discards valuable information and leads to inefficiency and inaccurate predictions. To retain some of the information, we propose here to enrich the masked state with the prediction of previous states. We achieve this by building a weighted superposition of the masked state and the embedding of the top k previously generated tokens. Thanks to enriching the masked state, soft masking improves the decoding accuracy and speed. Soft masking's implementational changes to standard masked diffusion models are minimal. During inference, we first compute the standard forward pass of the denoising transformer and unmask a certain portion of the predicted tokens. Then, we enrich the masked tokens by computing the weighted superposition between the mask and the top k predicted tokens from the denoising model, all in the embedding space of the denoising transformer. Importantly, soft masking maintains the dimensionality in both the temporal and the spatial domain. Moreover, soft masking only adds 3 additional learnable parameters. Therefore, soft masking is a highly efficient addition to masked diffusion models. The training, however, needs some adaptation, as computing the marginals becomes intractable. Therefore, we use self-conditioning, where we pass the noised sequence through a frozen transformer, which allows us to compute the soft masked sequence. We can then pass this soft masked sequence through the denoising transformer to compute the loss. As this training method requires a second model-forward pass, we distinguish between a ISO-update training mode with the same number of training steps as comparison models and a ISO-compute mode with half the number of training steps, therefore requiring strictly less flops than comparison methods. I first show that soft masking improves language modeling on the open web text dataset, where we train a 168 model from scratch. In terms of validation perplexity, our soft masking outperforms both masked and uniform enhanced baselines. Particularly, our ISO-update model outperforms another ISO-update LDDM, which is a concurrent work at ICLR that also aims to enrich the masked states. In unconstrained generation, our soft masking achieves highest quality, outperforming both the binary baseline and CAT, yet another concurrent work at ICLR. Finally, soft masking can benefit from advanced unmasking strategies, such as re-MDM. As our soft masking does minimal changes to masked diffusion models, we can also fine-tune a pre-trained model to perform soft masking. Indeed, we find that soft masking enhances the DreamCoder7b encoding tasks, particularly in low NFV budgets. We also show that soft masking can be natively integrated into other performance enhancement frameworks, such as FastDLLM, which introduces caching and parallel sampling. Here we find that soft masking can indeed push the Pareto front on accuracy versus throughput. To conclude, we present soft masking that enriches the masked state in diffusion language models. We propose a training methodology based on self-conditioning. Thanks to soft masking's minimal adaptation, we can train the model from scratch, or also fine-tune an already pre-trained model. Soft masking achieves state-of-the-art language modeling performance among diffusion language models and improves DreamCoder7b encoding, particularly in high throughput settings. If you're interested, check out the open source code and the paper. Thanks.